Okay, so this is the notes for section 4.1, reflecting points. If you haven't done so already, why don't you pause the video and read section 4.1 before continuing on. First thing we're going to look at in these notes is the definition of reflection, or the definition of reflection image. And I'm just going to read it to you, and then we're going to try and kind of break that down a little bit. It says, for a point P not on a line M, the reflection image of P over line M is the point Q if and only if M is the perpendicular bisector of PQ. Okay, I'm going to stop right there because that's generally we'll refer to that as the first part of the definition of reflection. Let's look at what that means. So what that's saying is that if I have a point and I'm reflecting it over line M, then what we're saying is that this line must be the perpendicular bisector of this segment. Okay, and if we think back to the last chapter, perpendicular bisector means that it's going to divide the segment into two equal segments, and it's going to form a 90-degree angle with the line segment. So anytime we're reflecting points, we need to make sure that the image and the pre-image, that line segment, when I look at it in relation to the reflection line, that reflection line will always be the perpendicular bisector of that segment. And you'll notice whether it be E, L, or F here, all three of the points that we have on this dog, this line is the perpendicular bisector of those segments. Okay? The second part of the definition of reflection says the following. For a point P on M, the reflection image is P itself. And I have an example of that right over here. So P is on line M. The reflection over line M of P is P itself. Okay? Okay, next I'd like to take a look at the notation that we use when we do reflections. When we're discussing reflections in general, or when the reflection line is obvious, we're going to write it like this. Okay? The reflection of point A is A prime. Okay? If we don't know, if the reflection line isn't obvious, okay, if we need to really define which line we're reflecting over, then we're going to write it like this. The reflection over line M of Q is P. Okay? And that's the way I'll generally write it, or read it, excuse me. The reflection over line M of Q is P. Okay? Obviously, is and equals are interchangeable, but that's how we'll read it, and that's how we'll write it. Okay? This is the same notation really that we used when we were looking at rotations in chapter 3 and size transformations in chapter 3, and we're going to be consistent with that. It's also the same notation that we're going to use next year in algebra when we look at functions, and it will be referred to at that time as function notation. So let's take a look at example 1 here in your notes. It says, in this diagram, the reflection image of P over line B is Q. Name Q using reflection notation. So basically what we want to do is we want to refer to point Q as a reflection image of point P. Okay? So to do that, we're going to write it like this. The reflection, so that small r represents a reflection. Over line B, the B represents the line that we're reflecting over. Of P, P is the point that we're reflecting, right here, is Q, the point, or our image point. So P is my pre-image, that starts right here. Q is my image, so that's what I end up with. Okay, next I'd like to take a look at example number 2 here. And in example number 2, what we're doing is we're looking at reflections on a coordinate grid. On a coordinate grid, reflections are actually relatively easy because the distance from the x-axis or the y-axis can easily be measured because based on the coordinates that were given. So it says in example 2, it says find the image of the point 5, -2 when it's reflected over the y-axis for part A and over the x-axis for part B. So let's look at part A first. If I'm going to reflect this point 5, -2 over the y-axis, we know that the y-axis has to be the perpendicular bisector of the segment connecting the image and the pre-image. Okay? So that means that the distance from this point to the y-axis has to be exactly the same distance as the distance from that y-axis to where it ends up. Okay? Well, I know based on my coordinate that it's 5 units from the y-axis. Therefore, when I put it over here on this side, I've got to come over 5 units as well. And I need to place it right there. So the point that I would end up with would be -5, -2. Therefore, my answer here for the reflection over the y-axis would be -5, -2. Okay? Now, if I take that same point, and this time now I'm going to reflect it over the x-axis. Okay? Well, here's my x-axis. So once again, the distance from the point to the x-axis has to be exactly the same as the distance from the x-axis to the image point. So this would have to be my point, which would be 5, +2. And notice how now instead of the x values changing, the y values changed, and the x values remain the same. So this would be my image point, or excuse me, 5, 2. I'm sorry. So this is the answers to part A and part B. Now, this leads to a general statement of any reflection over the x-axis or the y-axis on a coordinate grid, and that is the following. If I do the reflection over the x-axis of any point xy, it will always become x -y. In other words, all we need to do is change the sign and the y value when we're reflecting over the x-axis. And when we do a reflection over the y-axis, all we need to do is change the sign on the x value. So whichever axis we're reflecting over, we're going to change the sign on the other one. Okay? Now, one other thing that I'm going to say is sometimes in terms of notation for this, instead of x-axis here, we might do the reflection over the x-axis and just put an x down there of the point xy. Okay? These two things mean exactly the same, and same here, I could say the reflection over the y-axis of xy. So instead of y-axis, I might just put y. Those two things mean exactly the same thing. Okay, now what I'd like to do is take a look at how we can do reflections without a coordinate grid. If I'm just looking at reflecting a figure over a line using a ruler and a protractor, we know that when we perform a reflection that the reflecting line has to be the perpendicular bisector of a pre-image point and its image point. So to do that, what we're going to do is we're going to take our ruler protractor that you use in your science course, and I'm going to place the ruler such that it's perpendicular to the line. So I'm going to put the 90 degrees mark on the line so that the ruler is perpendicular. Okay? The next thing I'm going to do is I'm going to measure the distance from the pre-image point to the line. Okay? So I need to move my ruler such that it's in line with one of the points. So I've zoomed in here a little bit, and I've got my ruler such that it's at 90 degrees and it's on one of the points. I'm going to start with this point right here. Now what I'm going to do is I'm going to look at on the ruler, and I believe this is in tenths of an inch here, so it looks like it's a little less than 2/10 of an inch on that side of the line. So I'm going to come on this side of the line and plot where that point would be right along that ruler. Okay, so that would represent my image point, and then I'm going to repeat the process for the other 2 points. So with this point here, you can see that it's a little bit more than 1.2 inches in this direction, so I've got to come 1.2 inches in the opposite direction. So that would be somewhere right around here. And with the last point, it's also a little over 1.2 inches from the line. Therefore, I'm going to come right over here and plot my final point. Then I pull my ruler away, and then I'm going to connect those points. So that's how we can reflect using a ruler and a protractor.